Brahmanda universe. In ancient India, between the 15th and 12th centuries BC, there's this remarkable text known as the Rig Veda. It tells this mind-bending story about the universe being like a giant cosmic egg. Picture this. From a tiny point called a bindu, the egg expands, filling up with everything: sun, moon, planets, you name it. Then it pulls a cosmic disappearing act, collapsing back in on itself. But here's the kicker. It doesn't stop there. Nope. It's like the ultimate cosmic yo-yo, expanding and collapsing over and over again, forever. Anaxagorian universe. Picture togas, sandals, and minds as sharp as a Spartan spear. Ancient Greece, where Anaxagoras, a pre-Socratic philosopher from the 5th century BC, was pondering the cosmos. Anaxagoras believed the original state of the cosmos was a mixture of all its ingredients which existed in infinitesimal small fragments of themselves. This mixture was not entirely uniform, and some ingredients were present in higher concentrations than others, as well as varying from place to place. Then, he proposed that a cosmic mind set this mixture in motion, causing it to separate and form the diverse cosmos we see today. Atomist universe. Later in the 5th century BC, the Greek philosophers Leucippus and Democritus founded the school of atomism, which held that the universe was composed of very small, indivisible, and indestructible building blocks known as atoms, from the Greek atomos, meaning uncuttable. All of reality and all the objects in the universe are composed of different arrangements of these eternal atoms and an infinite void in which they form different combinations and shapes. Aristotelian universe. The Greek philosopher Aristotle, in the 4th century BC, established a geocentric universe in which the fixed, spherical Earth is at the center, surrounded by concentric celestial spheres of planets and stars. Although he believed the universe to be finite in size, he stressed that it exists unchanged and static throughout eternity. Aristotle definitively established the 4 classical elements of fire, air, earth, and water, which were acted on by 2 forces: gravity, the tendency of earth and water to sink, and levity, the tendency of air and fire to rise. He later added a 5th element, ether, to describe the void that fills the universe. Stoic universe. The Stoic school of philosophy was founded around the early 3rd century BC, with its roots attributed to the teachings of Zeno of Citium in Athens. Stoicism is based on 3 main pillars: logic, ethics, and physics. The Stoics believed that the cosmos is God, or what we call a pantheistic God, one which is rational and creative and which is the basis of everything which exists. Thus, Stoic ethics are guided by nature. They also believed in a kind of island universe in which the cosmos is finite and surrounded by an infinite void. They held that the cosmos is in a constant state of flux or change and pulsates in size and periodically passes through sudden change and massive fire that destroys everything. In the Stoic view, all parts of the universe are interconnected, so that what happens in one place affects what happens elsewhere, like a domino effect. They also held a cyclical view of history, in which the world was once pure fire and would become fire again, an idea borrowed from Heraclitus. Heliocentric universe. The 3rd century BC Greek astronomer and mathematician Aristarchus of Samos was the first to present an explicit argument for a heliocentric model of the solar system, placing the sun, not the Earth, at the center of the known universe. He described the Earth as rotating daily on its axis and revolving annually about the sun in a circular orbit, along with a sphere of fixed stars. His ideas were generally rejected in favor of the geocentric theories of Aristotle and Ptolemy until they were successfully revived nearly 1800 years later by Copernicus. However, there were exceptions. Seleucus of Seleucia, who lived about a century after Aristarchus, supported his theories and used the tides to explain heliocentricity and the influence of the moon. The Indian astronomer and mathematician Aryabhata described elliptical orbits around the sun at the end of the 5th century AD, as did the Muslim astronomer Jafar ibn Muhammad Abu Mashar al-Balkhi in the 9th century. Ptolemaic universe. The 2nd century AD Roman-Egyptian mathematician and astronomer Ptolemy described a geocentric model largely based on Aristotelian ideas, in which the planets and the rest of the universe orbit about a stationary Earth in circular epicycles. This was perhaps the most successful cosmological model of that time. Modifications to the basic Ptolemaic system were suggested by the Islamic Moraga school in the 13th, 14th, and 15th centuries, including the first accurate lunar model by Ibn al-Shatir, and the rejection of a stationary Earth in favor of a rotating Earth by Ali Kushji, partially heliocentric universe. In the 15th and early 16th century, Somayaji Nilakantha of the Kerala School of Astronomy and Mathematics in southern India developed a computational system for a partially heliocentric planetary model in which Mercury, Venus, Mars, Jupiter, and Saturn orbited the Sun, which in turn orbited the Earth. This was a kind of hybrid of the Ptolemaic and Copernican models. Copernican universe. In 1543, the Polish astronomer and polymath Nicholas Copernicus adapted the geocentric Maragha model of Ibn al-Shatir to meet the requirements of the ancient heliocentric universe of Aristarchus. His publication of a scientific theory of heliocentrism stimulated further scientific investigations and became a landmark in the history of modern science, sometimes known as the Copernican Revolution. Cartesian Vortex universe. The Cartesian Vortex universe was a cosmological model proposed by René Descartes in the 17th century. According to his model, the vacuum of space was not empty at all, but was filled with matter that swirled around in large and small vortices. Descartes' model depicted a static and infinite universe, challenging earlier views of the cosmos. Newtonian universe. In 1687, Sir Isaac Newton published his Principia, which described, among other things, a static, steady-state, infinite universe, which even Einstein took as a given, at least until events proved otherwise. In Newton's universe, matter on the large scale is uniformly distributed, and the universe is gravitationally balanced, but essentially unstable. Hierarchical universe. Although still generally based on a Newtonian static universe, the matter in a hierarchical universe is clustered on even larger scales of hierarchy, and is endlessly being recycled. In this model, matter is arranged in a nested hierarchy of structures, from individual stars and galaxies to galaxy groups, superclusters, and beyond. It was first proposed in 1734 by the Swedish scientist and philosopher Emanuel Swedenborg, and developed further independently by Thomas Wright 1750, Immanuel Kant, and Johann Heinrich Lambert, and a similar model was proposed in 1796 by the Frenchman Pierre-Simon Laplace. Einsteinian universe. Albert Einstein's theory of general relativity reshaped our understanding of gravity and the cosmos. Introduced in 1915, Einstein's field equations describe how the geometry of space-time relates to the distribution of matter and energy. Later, Einstein included a cosmological constant to maintain a static universe, but he later dismissed it as a mistake when evidence suggested the universe was expanding. However, modern observations have revived interest in the cosmological constant, indicating that Einstein's insights remain relevant and profound in our quest to understand the universe's workings. Big Bang universe. Following Hubble's demonstration of the expanding universe in 1929 and the discovery of cosmic microwave background radiation by Arno Penzias and Robert Wilson in 1965, the Big Bang theory became the mainstream scientific view. This theory states that the universe originated from an infinitely small, dense point called the singularity around 13 to 14 billion years ago and has been expanding since. The foundational concept is often credited to Belgian physicist Georges Lemaitre in 1927, though a similar idea was proposed by Russian physicist Alexander Friedmann in 1922, based on Einstein's general relativity equations. Oscillating universe. This was Einstein's favored model after he rejected his own original model in the 1930s. The oscillating universe followed from Alexander Friedmann's model of an expanding universe based on the general relativity equations for a universe with positive curvature, which results in the universe expanding for a time and then contracting due to the pull of its gravity in a perpetual cycle of Big Bang followed by Big Crunch. Time is thus endless and beginningless, and the beginning of time paradox is avoided. Steady state universe. This non-standard cosmology model, opposed to the standard Big Bang model, has occurred in various versions since the Big Bang theory was generally adopted by the scientific community. A popular variant of the steady state universe was proposed in 1948 by the English astronomer Fred Hoyle and the Austrians Thomas Gold and Hermann Bondi. It predicted a universe that expanded but did not change its density, with matter being inserted into the universe as it expanded in order to maintain a constant density. Despite its drawbacks, this was quite a popular idea until the discovery of the cosmic microwave background radiation in 1965, which supported the Big Bang model. Inflationary universe. In 1980, the American physicist Alan Guth proposed a model of the universe based on the Big Bang, but incorporating a short, early period of exponential cosmic inflation in order to solve the horizon and flatness problems of the standard Big Bang model. Multiverse universe. The Russian-American physicist Andrei Linde developed the inflationary universe idea further in 1983 with his chaotic inflation theory, or eternal inflation, which sees our universe as just one of many bubbles that grew as part of a multiverse owing to a vacuum that had not decayed to its ground state.